Aloha, Richard Halverson here. This is ITS128, and today is December 1st. So let me share my screen. And we are at December 1st, which is like this week. And so today we're going to start chapter 9, which is classes. And so I'm going to try to get through the first 2, 3, 4 sections and maybe do get you started on a couple of little labs. All right, so if you go to Zybooks, go to the class. This is the URL for the class. We're in chapter 9. Let me open up my chat here and make sure that. So classes. Okay, classes is we've been using classes all along, but now we're going to sort of understand the basics of them from an academic point of view, and then how to write our own classes. So if we start, let's just go through a couple of sections here, and so we're starting out with the concept of classes and an object. If your book looks like this, and so you can read it. But I'm going to try this presentation view today. There's a concept of an object. And in programming, an object is just a group of variables and methods. Methods and functions mean the same thing. Back in the old days, we just called them functions, but then about the time classes came around, it's like they had to have a new name for it or something, so they call it methods. Variables are called variables. We also call them properties. Can also call them properties. So variables just hold values, and you can change them. Whereas methods and functions, they actually do things. They'll take several variables and mishmash them together, do some operations, and then return one or two variables or whatever. So back in the old days, before we had object-oriented programming in classes, we really did think of the world in this picture here. The world is viewed not as materials, but rather as objects. And so when you look at this picture here, the programmer would see this as, it's got some green fabric there, got some wood, red fabric, some more wood, and a metal bar, and so on. But really, a human views this as, there's a chair and a couch and a drawer, I guess. And now these objects, they are made up of these things that we see, these materials that we see. But also, there are certain things that you do with a chair that you maybe don't do with something else. Okay, a chair and a couch, you sit on both of those. That means something. A couch, you can also lie down, and so on. Anyway, so this is, if you click on the participation here, you can see that we see this, but people think of them as objects, and these are the materials. These are like attributes or the properties or the variables. And then there's also these methods here, these functions. You can sit on them, lie down on this one, cannot on this one, and so on. Drawers, you don't sit on a drawer. So you should go through this. This reinforces the concept here. Here we're talking about restaurants and hotels, and these are like the variables, the properties, and a restaurant has those. This is one for restaurant, one for hotel. Hotel has those, but also hotels also, there's also these methods that you also think about when you're thinking about a restaurant. You know, it's got a phone number. You can add in this particular context, you add a cuisine, you add a review. You want to print out the cuisines and so on. And for a hotel, it's similar, but not. There's some things that are different. So this concept of an abstraction occurs when a user interacts with the object at a higher level, and then the inner details remain hidden to the user. They're not hidden to the programmer. The programmer has to write them, has to implement these things. But so we don't think about like the variables that go along with doing some of these functions. There's some hidden variables and some hidden operations and so on. There could be some hidden functions, hidden methods to accomplish these things that the user sees on the outside. But that's where this abstraction concept comes from. And along with that is information hiding. There's information about lower level internal details that remain hidden. This concept of encapsulation occurs when the user interacts at the higher level, and then the lower level remains hidden, and it's all grouped up. It's all with respect to the one object, like to a couch. Okay, so there's functions that go along with it, and there's variables that go along with it, and that's all encapsulated into one object, and that's this concept of abstraction. And a class or an object that we define, or that you define as a programmer, it's the class of data type is called an abstract data type. That as opposed to just an integer or a string or whatever. These are abstract data types because there's a lot more to it. Now with integers and strings, you also have methods that go along with that, as you see, that are built into Python. But in this chapter, we're learning about how we create our own. All right, so this is kind of a funky participation example here. It talks about objects in a restaurant, or actually the restaurant itself, and we see this as an oven, and there's certain functions that we can do on it, but we might not even know if it's heated with gas or electricity, for example. On the outside of my oven, it doesn't say anything that would give it away. It's not till I open it up and I look inside, I can tell. You know, there's things that you don't need to do, like if you need to adjust the temperature, you know, you don't do that. There's a knob in front and so on. But anyway, a restaurant itself has these things inside, and that's how it produces the output. But even these things are abstracted away. So here's an example of with Python has these built-in types like strings and integers and so on, and it turns out that that there are methods that automatically go along with it that you can operate, that you can use to operate on these things. If you have a variable and you set it equal to this, that's a string, then Python says, oh, it's a string. Well, you can do all these things. All these methods come right along with it. You can test to see if it's all lowercase letters. You can even set them to all lowercase letters. You can split them into, you know, a list of characters and so on. And then when you go this one here, Python sees, oh, that's an integer. And so along, you know, it's a number. So along with that, you have these kinds of functions, methods. You know, these ones up here don't make sense for a number. So anyway, all right. So so now we're ready to define classes. And a class, it's confusing. When you know, I started programming long before we had a concept of a class, and so um, um, up until we had classes, and up until the time there were languages where when we're learning programming now, we start out with classes right away. There's not any really thing. There's not really any code that we write that doesn't involve defining a class or classes or using classes. But the term just kind of class with a classroom. You got a bunch of students, and you try to relate this concept of a class or the name to the concept, and to me, it really still doesn't quite click. Although it kind of does, but up until the time there were classes, we wrote code as, you know, respecting these concepts. I mean, we would write, you know, there was no defining a class and then defining a bunch of methods that could only operate on the variables inside that class. We just wrote, you know, functions that could operate anywhere, and we had variables all over the place. But conceptually, we grouped them up. You know, we sort of grouped them together in our code, and we always used those together. And then we defined some functions, and we only use those functions on those variables, even though there was nothing to keep you from writing. You know, when you're writing code to make these functions operate on anything. So then when object-oriented programming came along, you know, they sort of forced programmers to do this because they realized that this is the way to go. So all of this, this whole chapter is concepts, and it's the whole concept is you define this thing called a class, and that's like an object, it's like a chair, and then you can make multiple chairs, okay? And sometimes, you know, you make another chair and you're able to change the color of it, but it's not like you can change a chair into a couch, okay? So so that's what all this is. That's what this is about, and we're learning how to express all this, and you know, how to write a program that that integrates all these concepts. All right. So so when we're defining a class, we start out with a keyword class, and it's got a name, and then we got a bunch of statements here, and that's sort of the class. I don't have it where I can shut. Now, so once and a class has attributes which are just variables. No, actually, they're both variables and methods. So that's the thing. That's the thing. The things underneath this class definition that give it its behavior or defines it the way it is. And then what do you do? The defining a class doesn't take up any space. Doesn't take up any programming space, or it takes up program space, but it doesn't take up any space when it's running. It's using the class. Now you define a class. That's just like defining a string, and now you can make variables. You can define variables, define a bunch of variables, and they can all be strings. Okay, you can define a bunch of variables, and they can all be of your class type. And so doing that is called instantiation. You're creating an instance of it. It's fancy naming. And so you're creating an instance of it, and a method is a function that's defined inside a class, and it only its world or its scope is only the stuff inside the class. So that's kind of the difference between a method and a function. A method more we're talking about a function that's defined for a particular class, whereas as you know, functions like there's certain functions that do not have to be attached to a class, like the square root function, although it is often attached to the math class, but there are some functions in Python where like int. If you want to convert something into an integer, you say int parentheses and then the thing that you want to convert it into. Those are called functions. Those aren't the terminology. It's better to call those functions than methods, although methods is fine. Okay, so there's this init method, and what that is when you're creating a new instance, you're creating an object from a class, you can a variable. The method that's named this 2 underscores init 2 underscores, that's called the constructor. That's the function or the method that executes to set everything up for a new variable, a new object. And you may want to have some properties or some variables in there, and you maybe want to initialize them to 0, or maybe you want to initialize them to something else. That would all take place inside this method. It's called the constructor. Okay, so here's an example of a class called time, and this is when you create a new instance and create a new variable using this type. This executes, and what this basically does is this says, okay, there's going to be a variable called hours, and we're going to initialize it to 0. One called minutes, initialize it to 0. So then when you use it, say this is the class type, you create a new variable, a new object. We're going to call it my underscore time, and it is a time object or class. It's an object of this type, and then you can go ahead and set the properties. You set the hours property and the minutes property, and then it goes on its merry way. I don't see anything here that increments it to change. You still have to change the time, I guess. Anyway, and then so here you can print out, you can print out hours that way, and you can print out minutes that way. My time is the name of the object that you created. If you create another one, it's going to have a different name. And these are properties that were set inside here. This sets this inside here to find anyway. There's the way this here it explains this dot. It's this dot here. You use the dot when you're referencing a variable, and you also use the dot if you want to do a method thing too, if you want to do something. Dot notation. So here, just an example, we got this little time class, and we're making 2 of them. Making 2 of them. And so here, this one we're going to set to this time, and this one over here, time 2, we're going to set to this time. So when you print them out, they're going to be like that, different. Okay, here's a challenge activity, and what I'd like to do is just as I always do, I want to make sure you understand what they're asking for in the challenge activity, and then you can go ahead and do it. So let's take a look at this. Here we're defining a class, and we're using it, and we are setting name to username. Name is oh no, this is just a separate variable having nothing to do with the class called ABA, and it's set equal to ABA. It's a string, and then we have a string here, and we're going to anyway. So let's so when we print it, we're actually just printing this plus this, because this is the same as this is the same as this. Okay, so let's see what the next one is. Person Amy, this is Amy. Yes, person 1 is, okay, and we're setting person 1 equal to Amy. This is Amy. enter because it's a print. See, so anyway, you can, that's what we're doing there. All right, here's a challenge activity. I'll tell you how, let's make sure you understand. There's 2 challenge activities. So declare a class named patient data. Okay, so we're making a new class, and then we're gonna be able to use it down here. We see so here it's a new class called patient data, and it contains 2 attributes: height in inches and weight in pounds. And so when we're defining our class, it's got to do something with those. Make variables for those. Here down here, we're using it. We're creating an object of that type, and the first thing it does is it prints out. It looks like we're printing out what the default values are, and this is what the output. This is the execution of this program. So the first time it looks like we're just printing the default values, and then we ask the user to enter in a new value for height and a new value for weight, and then we print that out. See, so we set these variables equal to that, and then we print them out. And so we're supposed to write this class. So what you're going to do is you're going to do something like class, and it's going to be called patient data. And it doesn't take any doesn't colon, and then you're going to do some sort of def init, and you always put this self thing there, and basically what that is then inside here, inside this, so this is a method. So now you put something in here like something to initialize height inches, and then you also want to put something in here to initialize weight pounds, and I think that's all you got to do. Right now, and also, so let me just remind you that it's often nice to go over and use your editor, and I'm going to paste my code right in there, and I'm going to save it. It's called test.py. I'm going to save it. It's on my desktop, and I'm going to go and just to remind you, I've installed Python 2 as Python, and I've installed, just exit out of here, and I've installed Python 3 as py. So I use py, okay. I'm writing code. Okay, so I'm just gonna say, well, I'm just gonna try to run this, see what happens. I don't think it's gonna work, but so py test.py. Okay, unexpected indented block. Okay, there's got to be something here. So I'm going to say I equals 0. What does that do? Okay, so the problem is it got to this point, and it tried to print out some an attribute, a property, a variable of this object called height inches. And there is no height inches here. There's nothing defined as height inches. Anyway, so you need to fill this in and basically just make this work and make this work. And you got to be able to read it and write it. All right, so that you should be able to do that. Okay, what's this one? This one is print the attributes of inventory, print the attributes of the inventory tag object, red sweater. Okay, so there's this, there's a class here called inventory tag. Oh, look, this gives you a nice clue as to what the answer should be up here. See, it's got that and that and that. Okay, so these are these attributes. So in this code here, we use this class, and we create an object called red sweater that is of this class. And the first thing we do is we set a property, a variable called item ID. Oh, look, there it is. We're going to set it to something that we ask the user to enter in for us. And we turn it into an integer and get stored in there. So it's going to get stored up in there. And then we do the same thing for quantity remaining. It stores it up in there. And then we're supposed to print this out. So, you know, it's like copy, paste. So it's like print, this reads them in, and then we just need to print them out here. You know, that's easy. You just write two print statements. Print out item ID, but you have to refer to it like this, and then print out. Print out ID first. You got to print out ID, comma, and then the item ID, and the print out QTY colon, comma, and then quantity remaining. Okay, so that should be real easy. All right, moving right along. All right, just checking to make sure we are recording. All right, so instance methods. So these are methods inside an instance. Basically, all we've talked about so far is variables that we can get at. Variables inside the object that we can get at from the outside. We can write into them and we can read them out. So now this is a method that we want to ask the object to execute for us. So here, this is a method that will print out some data about the object. It'll print out the hours and it'll print out the minutes. It looks like it'll print it out all on one line. And so here is how we're using it. We're gonna make a variable called time1, and it's going to be of this class, the thing we just defined here. And so along with that comes the ability to read and write a variable called hours, read and write a variable called minutes, and then ask it to execute this method here. And so here we're setting the hours equal to something. Here we're setting minutes equal to something. And here we're asking it to execute this method. And what happens is this thing prints out because we set it equal to 715. So here we can run this. What is this method supposed to do? Oh, calculate pay. So we're supposed to, okay, so we create a new object, employee object called Alice. set a wage, set hours worked. This is horrible. And then we set a new, oh, and then we print it out, and we print it out using a method called calculate pay. So it's just going to print out some pay value, I guess. And then we create Barbara, and we create another one here, and hours worked, and that's just okay. So we just have to write this. So we got to do something like def calculate pay, and I should do the self thing, and we say pay equals, and it's just going to be an internal variable, so I don't need to do anything. I don't need to prefix it with anything. Pay equals self wage plus self hours worked. There might be something wrong with that that equation, but I'll let you figure that out. And then we're just going to return pay. So if we run this, so 35 times 19. See, well, it's obviously it's wrong because my expression here is wrong. Anyway, so that's how these work, and you can figure out how that works. A special method name indicating the method implements some special behavior of the class. Okay, so this is is there an example of that or something? Okay, well anyway, this just points out that you got to make sure you put the word self in there, because that's it. By the way, it doesn't need to be self; it can be anything, but you just got to be consistent. So when this is, it's going to be this name. The first parameter that comes in is a reference to itself. So this is what this is. So that's why you got to put self here. And then you're able to reference wage, which is a property of its its own property value wage. Okay. So anyway, so this shows what the error is, and you can confirm that. Okay, here's a challenge activity, and here we are creating an instance of a person. We're setting the first name, and we're printing the first name. Oh, we're printing it this way: you are, and then the first name. And see, so here we're using self, and we're using self, and here we're able to reference the first name property of itself. And so that's why it prints you are Bob followed by a return, because there's a print statement. So if we do the next one, we see it's just I am Joe. I am Joe. Okay, so you can do those. Here's another challenge. Define an instance method. This is a method inside of a class called IncNumKids. And it's so you can do this. You can execute that. No, for this thing, this method increments the number of this variable, this property. So it's so if we look down here, we got this class called personInfo, and when an instance of this class is created, this variable here is defined and set to defaulted equal to 0. And then we're supposed to write this method called IncNumKids. And basically we're just adding 1 to this. So that's the answer. Solution goes here. We're just adding 1. Def, it's got to be called IncNumKids self colon, and then we got to put the statement here to add 1 to it. Self num kids equals 1. Ha ha ha. So this is the wrong answer. Let's see what happens when you enter in a wrong answer. Oh, yeah. All right, anyway, you can fix that. Okay, how far are we going to go today? Let's go to student 9.4. Actually, we're going pretty quickly here. All right, so class and instance object types. Okay, so a class object acts as a factory that creates instance objects. All right, so sure, acts as a factory. I don't know why it says that. Anyway, so this is our class, and here we're using it to make 1, and then we're using it in to make another one, and we're setting some things. And so let's execute this, see what it looks like. Okay, this thing executes, and this thing executes, and it creates oh no, we haven't gotten there yet. Okay, this thing executes, which I'm gonna make this smaller. And then it creates the variable. This is the variable that's inside the time1 object. Okay, so it's done that. Where's the other one? Oh yeah, right. No, this is I did that. Okay, so here after it executes this one, then we're done with that one, and then we go down and we set this one. We set out. This is going to turn into 5, and this is going to turn into 30. And then we're going to set that to 30, and then we're going to do it all over again, but with a second object called time2. See, this is only time1. And so when we forward this, we're creating another instance, and so this is executing again. And we are creating these new variables, slots here. And then we're going to execute, once we're done with this, we jump back down to here. And then we're going to set that equal to 7 and set the next one equal to 45. Anyway, so so that's exactly, so this is what's going on inside conceptually. Well, these are actually memory locations here. And so so that's what's going on inside, and you should have been able to picture all this in your head based on what we have covered before. But all right, so there's I've been calling them attributes, properties. You can call them variables, but basically it's just the static slots that hold data. It's not code that does something. It's just a storage place. And attributes, and there's class level attributes, and there's what we can call instance level attributes. So a class attribute is shared amongst all the instances of that class. So if we have a class called Marathon Runner, this up here, this is defined above any methods. Okay, It's a variable that's defined above that, and we set it equal to something. And so every object that is created from this class, okay, gets this race distance variable, but also you can change it. So you can change marathon runner. You can change it to something else. Where does it show that? Anyway, you can change it to something else, and it changes for all the classes. Whereas an instance attribute is inside, it's defined underneath the init, where the init where all the other properties or the other attributes for an object are defined. All right. So here's we talk about namespaces, and it just has to do with where they're defined and it's how broad the reach is. If it's defined up here, then that's an attribute that's shared by all the objects. Whereas if it's defined down here under the init, that's separate for each object. So here's an example of where you're actually writing into here. So you have this object, or so you have this class called time, and it's got hours and minutes, and it's got this GMC offset variable, which is presumably it's a time zone. It's the time zone. Hawaii is -10. Pacific Standard Time is -8. So in this example, you create a time 1 and a time 2 based on this class, and you set the hours, you set the minutes for each of them, and then you print them out, and then you print them both out, this one and this one, and then you change the time zone. And here, you notice here you're referencing the name of the class, whereas all these other places, you're referencing the name of the object. So this is the name of the class, and you're changing that. You're changing the time zone to -8, so it prints out Pacific Standard Time instead. Okay, so that's instance attributes versus class attributes. So here you have a shape class called shape, and it defines when you create a new shape, an object of this class, the color is initialized to none, and so here you're setting it to something. So here you define shape 1, and you're not setting the color to anything, but then you define shape 2 and you do set the color. So you notice when you print the color of shape 1, it's none, and that's that. So let's do one. So here it's indigo. Shape 1 is going to be none, and shape 2 is indigo. Enter. Yes. Okay. So it's 4 o'clock. Boy, this is going fast. All right. So this is an example of a seat reservation system. That's all this is, and So we're just, this is just, so let's copy this and put it in our, over here. So we have a seat reservation system. Oops. Doesn't matter much. And this seat has 3 attributes. And when we create a new instance of a seat, we initialize the first name and the last name to blank, to empty strings, and then we say the paid attribute is equal to 0. And there's a bunch of methods here now. There's a reserve method, a make empty method. Okay, so the reserve method takes 3 parameters. The first one looks like it's the first name. The second one looks like it's the last name. And the third one looks like it's a value for paid. Okay, so that's what reserve does. It sets the first name and the last name and sets how much the person paid. There's another method called make empty, and that zeroes everything out. And then there's a test, which to test if the seat is empty, and then you test to see, and basically if it's true if the first name is equal to nothing. And then you can print a seat, and what that is going to do is it's going to print the first name here. So you do first name and then last name and then paid. So it's going to print first name space last name comma PAID colon and then the amount paid as a two digits to the right of the decimal point floating point number. And so that's the class, and this program here has got a couple of functions or methods that are not class related. There's this method here called make empty seats, and what that does is it goes through all of the list of seats. It goes through all the seat objects. It looks like we're making a list called available seats, and what we can do is, first of all, this method makes them all empty. Where do we define the list of seats? Oh, this is a list that comes in. So list that comes in, and for every seat in the list, we make them empty, which means we blank out the name and make paid equal to 0. And this, by the way, prints them all. Okay, just prints them all. It uses the print seat instance method here. All right. So it starts out by setting. We're going to have 5 seats, and so we're going to append a seat. This is a class. So it's going to be an object. This is a variable. This is an object of a seat class, and we're going to append it onto the list of seats. So there's going to be 5 seats in here because it's going to go from 0 to 4. 5 seats in there, and they're objects. They're objects of this type. And then this is a program that, and then here we're, it's, so let's, so this is a menu, P to print the seats, R to reserve a seat, and Q to quit. Okay, and so if we execute this at test.py, first thing it does is it asks us a command, and let's look at this data here. So I'm going to copy out all this data to make so I got it. Copy. I'm going to do a comment someplace. I'll do a comment right here. Okay, so first, I don't need this. First I say R, so I'm going to do R. And then I enter a seat number. I'm going to do 1. And enter first name, I'm going to say Hank. And then I'm going to say Hill. And then I'm going to say 275.63. Fine. Then I'm going to say R. A new reservation. Seat number 2. Bobby Hill. 245.22. And then I'm going to print. Look, there they are. Oh, because there is nobody in seat 0. There is somebody in seat 1. There is, Hank Hill. There is somebody in seat 2, and there's nobody in seat 3 and nobody in seat 4. Okay, anyway, so that's a cool program. Quit. All right. Let's get back to this. So that's 5. Okay, so we have covered 1, 2, 3, 4, 5, and then I can leave class constructors, class interfaces, and class customization for next time, or these 2 things also. I guess we're halfway through. Okay, so let's do some labs. Okay, let's start out by doing this one, 9/11. All right. So, all right, so complete the car class by creating an attribute called purchase price. It's an integer. And a method called print info that outputs the car's information. All right, so if the input looks like this, the input looks like the year, the model year, how much, purchase price. And then this is the current year, and it's gonna compute something. It's gonna purchase price is this. The current value is 5770. So there must be some formula that takes. Looks like it's 7 years old. Wait. 12, 13, 14, 15, 16, 17. Yeah, 7 years old. It depreciated that much, I guess. So let's look at this. Let's look at this. Okay, so all right, let's copy this. Copy, paste it over here. So there's got to be a purchase price attribute. Self dot purchase price equals 0, I guess. Let's probably initialize it to 0. Oh, it gives us the depreciation. Looky here. So this method calculates the current value. And the and it takes the current year as a parameter. It defines a depreciation rate, and this is an internal variable that you actually can't get at. No, you can't get at that. Car depreciation formula is the car age, is the current year minus the model year. See, self now is referring to the object. These are the properties, the attributes of a car. This, and this. And so when we calculate a value, it's this, the current value. When we calculate that, we take the original price, which is that, and we use this formula. Again, you don't. This is actually a pretty good formula, it turns, but you don't need to know the formula. All you need to know is to get this to work. And lucky you don't need to convert this from some mathematics way of writing it. It's interesting just to know we can do that though, by if we convert this, what this formula actually was, and that would be purchase price. I'm going to call it P, purchase price times 1 minus depreciation rate. I'm going to call that R. Depreciation rate to the car age power, age to the A power. And A equals age equals current year minus model year. So anyway, so normally you would have to take this and convert that into this. Okay, so anyway. Okay, so so they already give you the formula, and we initialize that, and then we need to make a print info. This is a method, def print info. And what we're going to do is we're going to print out, what is it supposed to look like? It's supposed to look like this. So I'm just going to be lazy, and I'm going to print year self dot model year, comma price, purchase price would be self dot purchase price, and current value self dot current value. And this I got to put self in here, right? Don't want to be fooled. Okay. By the way, you may wonder what this is. And all that is only execute this if this whole thing is running as the main program. And it is running as the main program. We run it here as the main program. By the way, what is it asking for? It's asking for the year, the price, and the current year. So the year is 2011. The price is $18,000. That's how much I paid for my jalopy, for my Hyundai, whatever. And then my the current year is 2020. And it says the years, so I'd be able to get that much for it. Anyway, you have to make an output like that. Okay. All right, 416, moving right along. Let's see what's next. Nutritional information. Okay. So constructors. So we're dealing with constructors. Looks like we got to write the underscore init thing here, doesn't it? Is that all we got to do? Is that all we got to do for this? All right, complete the food item class by adding a constructor to initialize a food item. The constructor should initialize the name to none and all other instance attributes to 0 by default. If the constructor is called with a food name, grams of fat, grams of carbohydrates, and grams of protein, then the constructor should assign each instance attribute with the appropriate parameter value. The given program accepts as input a food item name, fat, carbs, and protein, and number of servings, and it creates a food item. Okay, so a name, a grams of fat, grams of carbohydrates, grams of protein, and number of servings. And the first thing it does is it prints out like the initialization of it, because it's first we create food item 1, and we oh yeah, okay. This prints out the empty one first and then the one you entered in second. But it looks like here, create an item name. This is, okay, M&M's, whatever, 34, whatever. And then we create food item 2. Okay, food item 1 is empty. It's got no parameters. Food item 2 does. Okay, so the constructor has to be able to take these parameters, okay? Because this calls the constructor, and with all these parameters. So the constructor's got to be able to take these as parameters. They're optional parameters, I guess. Reads the number of servings. Get calories times the number of servings. Okay, number of servings. Okay, so we're using a method in there, and that would be this method. Okay, so I just have to write the constructor. So that would look like this. Def, let me copy, paste. Okay, so that would be def underscore init underscore, and the first thing always has to be self. And then we're going to input a name, and a, it's this. Okay, a name, a fat amount, a carbs amount, and a protein amount. Okay. And we can say self dot name equals name, and self dot fat equals fat, and self dot carbs equals carbs, and self dot protein equals protein. Now, you know, when I would see this back when I was trying to teach myself object-oriented programming after being a programmer for 20 years or so, this just was confusing to me. And the reason is because the names are the same. Well, it doesn't. You don't have to have the names the same. Let's call this is the attribute name. These are, here we're defining attributes, but this is this. So if you want to, we can just do like 1, 1, 1, 1, just to make them different, and in which case we're talking about these ones. Okay, so whatever comes in is, we're going to have that be set equal to that. So now the other thing is that we have to do defaults. So to do defaults, you just put them up here. This is going to default to nothing. Oh, I guess none. I guess none. And this is going to default to 0. And this is going to default to 0. And this is going to default to 0. Okay, so so if this doesn't come in as a value, if these parameters don't come in as enough, and you know, so in other words, if we're doing something like this where we're not giving them anything, then this is what it's going to be. This is going to be none. This is going to be 0.0. This is going to be 0.0, and this is going to be 0.0. Okay. I think this is all we got to do. So this is the constructor. This is the constructor. All right, so I should just be able to run this, right? Does it ask me anything? Enter a name. Enter grams of fat. Enter grams of carbs. Enter grams of protein. All right, I'm just going to run this. CLS. Enter a name. I don't know. Ice cream. Grams of fat. 10. Grams of carbs. I don't know. 100. Maybe not that much. Grams of protein. I don't know. There's probably some protein in there. And and food item 2. Is there oh, there's another input. Number of servings. Number of servings, 5. So here's the 0 and here's the 5 servings. Oh, that's calories. I see, this calculates calories, huh? All right, well, anyway, so you should know enough to be able to finish this. You basically just type in the constructor method. All right, well, see, I think this is pretty good. We've done pretty good. So thank you all for coming. Does anybody have any questions? If not, I will see you on Thursday. Thanks.
Thank you.